Ah, the dreaded loading spinner. The bane of every user's existence, but a necessity in a world where things are not instant. And when you're building front-end applications, you typically have to deal with asynchronous things, that is, requests to APIs or servers or whatever else. And in this video, I'm going to show how we can handle async state in both Vue and React. Now, this is the third video in a multi-part series where I'm comparing the same apps built with Vue and React. And like I said, this video is all about async state. And this basic example I have for you is just hitting an API, waiting for the response, displaying out the results, and it's also paginated so the user can actually page through the results. I also have a slightly more advanced example for you that deals with some of the other things you might come across in the real world, like slow requests and also the API returning errors. So in this example, the API returns an error 40% of the time. So let's see if we can get it to trigger an error. So you can search for something, get back the results, but if every now and then, yeah, it comes back with an error. Now, in the real world, you might actually retry this request behind the scenes. In this example, I just want to show that error to the user and then give them a button so that they can retry again and again. Now, another thing you typically deal with is managing multiple async requests and making sure that the UI stays up to date. Now, this is really erroring out. Come on. And what I mean by that is, let's say the user clicks next to go to the next page, but then clicks next again before that page is loaded, like this. What do? Because if you don't cancel that previous request, it's possible that the previous request resolves after the current request, and then your page is out of sync. And so in this example, I'll show you how we can cancel requests in flight and manage that on the front end as well. So let's dive in. My name is CJ. Welcome to Syntax. First, let's take a look at how I implemented this with React. Now you can see here I have the image search component and then lots of state variables. The first state variable here is input, and we are just keeping track of what the user has typed in on that state variable. Now I have a separate state variable for search term because essentially whenever the form is submitted, that's when I want to make the API request. So that's when I set the search term value. So here on the form, when it's submitted, we call our onSubmit function. And inside of here, I reset all of my state variables that matter, and then specifically set the search term state value. And that, in turn, fires off this useEffect. So useEffect is how we manage asynchronous things inside of React. And essentially, you pass in a dependency array, and when any one of those dependencies change, this function will rerun that we pass in here. And so in this case, I'm using that to my advantage. When the form is submitted, I'm just updating those state variables, and behind the scenes, this useEffect is going to rerun. Inside the useEffect, we reset a few more state variables. We reach out to our API, and then that API responds with an object that has some metadata, like the total number of results and the amount per page, and then also the photos themselves. So we use that data to calculate how many total pages they are, update our state with that list of photos, and then we're good to go. At that point, our page should re-render. And if we look at our render function, we have a place where we're showing that loading image. And then we also have a place where we're iterating over those images, and then also showing a message if there were no images at all. Now, if we take a look at the next and previous buttons, they are essentially just setting the next page. That's all they have to do because of the useEffect, right? So when we press the previous button, we take the current page and subtract one. When we press the next button, we take the current page and add one. And because we're updating that state variable, our useEffect up here is going to rerun because it's dependent on that state variable. So in the React example here, really the main thing to pay attention for async state is this useEffect here. And you will notice that I have to wrap my code that uses async await in an iffy, or an immediately invoked function expression, because useEffect cannot accept an async function. You'll see if I pass in an async function, I'm getting a type error, and that's because a useEffect can return a function. So this returned function here is known as our disposal function. And essentially, if this useEffect ever needs to be recalled, that is, its dependencies change, this function will run so you can dispose of things or change things up. In this example, I'm not disposing of anything, so I'm not actually returning a function, but I do have to wrap my code here in an iffy if I want to use async await. Now let's take a look at how I implemented this with Vue. So up at the top of my component, you can see here I have all these state variables. Again, we have both input and search term. If we look at our template, input is bound to that input there. And whenever that changes, that's getting updated behind the scenes. But whenever we submit the form, we call our onSubmit function. And inside of here, we check to make sure the user has actually entered something in, reset a few state variables, and then actually set our search term value there. Now inside of Vue, we have this function called watch, and watch allows you to pass in some reactive variables or a getter function that returns some value. And if its dependencies ever change here, the function that you pass in second will get recalled. And so that's how we're managing things here inside of Vue. If search term or page ever change, this function is going to get re-invoked. And here it's very straightforward. We just reset some state variables, call our API, and then update the page accordingly. Now, if we look at the template, we can see how we're using these state variables. First up, we have that loading image. So if loading is true, that loading image is going to show. And then here is where we iterate over all of our images and render out each image. And then we also have our message down here if there were no results from the API. Now, if we take a look at the next and previous buttons, they essentially just modify that page state variable directly, right? So when the next button is pressed, increase page by 1. When the previous button is pressed, decrease page by 1. And because it's modifying those state variables, this watcher is going to see that and then rerun our function here when they change. Now on the surface, both of these examples are fairly similar, but there are some caveats when using useEffect in React. So let's take a look at useEffect in React versus watch inside of Vue. Now in React here, let's actually see what happens if I navigate away from the image search page and then back. We actually see a flash of loading state, and you can see that API requests were made. And that's because in React, a useEffect is going to run the first time whenever a component mounts. So that's just the default behavior of useEffect. You can't change that. Essentially, when this component mounts, this useEffect is going to run with the initial values of both search term and page. And so that's why we're actually seeing the loading state flash to true. It's because this useEffect is actually running when the page mounts. Now, another thing you might have noticed is that it made 2 API requests. Now, this has to do with React strict mode. And there also is not much you can do about that. And so here in my React app, if we look how it's mounted, we're using strict mode. And so this was introduced, I think, in React 14. And essentially, it mounts your app and your components twice. And you need to make sure to take that into account. Now, for this example, I think probably the easiest way to make sure that we don't fire off 2 requests in quick succession is potentially wrap this in some kind of set timeout. So we, for instance, could have a timeout here, and then we'll call a set timeout. And I'm pretty sure this can be immediate. And then we can actually just move this whole function inside that set timeout like this. And then we can actually return a disposal function. So if we return a disposal function that calls clear timeout with that timeout, and so now if this useEffect is ever called in quick succession, the previous one will be canceled. And so this should get rid of our double request. So if I refresh the page here, we do only see a single request. But now we still are seeing an API request, and I don't actually want to call the API whenever the page loads. So probably the easiest way to fix it in this example is to probably just check to see if the search term value is set here inside of this useEffect. Another thing you could do is potentially create a ref that is how many times this component is rendered. And if the ref is greater than 1, actually allow this to be called. But for this specific example, probably the easiest thing to do is just say if the search term is actually set, or if it's not set, then don't do anything. So that would prevent that API request from happening when the page loads. But we should be good to go for all other types of requests like that. Great. But in Vue, we don't have to think about these same types of things. So by default, watch does not get called when the component mounts. It only gets called when these dependencies change. If we want this to be called when the component is created, there are some options for that. So watch actually allows you to pass in some options here, and you can say immediate true. And so this will give you the similar behavior where when the component is created, this function is called. But it's nice that we can actually opt into that if we want to. The other thing is inside of React, we typically use useEffect as kind of like our component did mount, if you remember the days of class components. So a lot of times in React, you might have a useEffect, and then that just has an empty dependency array. And you kind of treat this as your component did mounts because you expect that this is only going to run once because it has no dependencies. Inside of Vue, there is a specific method for that. So here there's a method called onMounted, and you can explicitly opt into when the component mounts. And so in Vue, you typically reach for the specific function depending on what you want to do. So here I can pass in a function to onMounted and then do the things I want to do when the component mounts. And so this is one of the things I like about Vue is you can be very explicit about how you're watching for variables and how your functions rerun. Whereas in React, it's kind of all or nothing. Essentially, all we have is useEffect, and we need to think about all the various scenarios where that useEffect might rerun or prevent it from running on mount. And so those are a lot of the things you do have to take into account when you're using useEffect in React. So that's it for the simple image search. Let's take a look at this advanced image search. So you might have noticed in the previous example, I was not accounting for errors. So if the API errored out, the UI probably would have just crashed. But in this example, I'm accounting for errors. So the API that we're calling here responds with an error 40% of the time. So 40% of the time, we're actually going to get back an error. So here, if there was an error, we're actually showing that error to the user. And this is the actual error message coming from the API. And we're exposing this try again button. So you could technically just have a few retries behind the scenes, but I want to expose this try again button so the user has the option to click try again, which will just refire off that request. And even the pagination requests could potentially fail, and the user should be able to retry those pagination requests as well. So first, let's take a look at how I structured this in React. And one of the main things here is because our code is getting more and more complex, I've actually extracted out all of that code that's calling the API and handling the errors into a custom hook. And so you'll typically see this in larger React applications where instead of defining all of that state and useEffect inside of this component, we can wrap it up into a nice reusable hook. And that kind of reduces the complexity that I'm looking at here inside of image search. But the rest of this function is fairly the same. Like even our onSubmit function is exactly the same. The only difference is we've kind of extracted out that logic and then from that hook, expose the specific things that this component needs. So let's take a look at that custom hook useImages. So this accepts the search term and the page. And inside of it is where we have all of the associated state variables and then also effects. And this custom hook is basically returning everything that needs to be usable by the outside world. Now for this example, like I showed, I wanted that try again button to be able to refire off the request. And so that's why in this custom hook, I actually am exposing fetch images to the outside world. Because inside of the component, that try again button needs to be able to fire off fetching of the images if there was an error. And so that's why I've structured the code in this way. And essentially what I've done is I've defined fetch images using useCallback. So useCallback is from React, and it allows us to define functions that will only get redeclared if their dependencies change. So it's very similar to useEffect, but specifically for defining callbacks or functions. And in this case, I only want fetch images to be recreated if page or search term change. So those are its dependencies. And then to get the behavior of actually firing off that request when those dependencies change, I have a separate useEffect. So this useEffect is dependent on fetch images. So if fetch images changes, that means that page or search term changed. And if that's the case, we want to refire off fetch images. So in this example, because I wanted that behavior of being able to call fetch images outside of this hook, I structured it this way so we can actually expose fetch images to the outside world. Now, here it's important that I wrap this inside of useCallback because a React component is going to re-invoke all of these use functions every time the component is rendered. But I need to make sure that useImages doesn't return a brand new fetch images function every time. It only returns a new one if page or search term have changed. So that's the basics of this custom hook here. We also need to handle canceling requests, but before we dive into that, let's take a look at how we implemented a similar reusable function inside of Vue. So here's our component, very similar. Again, we just have our state variables here, but we've wrapped up all of that functionality into this reusable function here called useImages. And useImages accepts both the search term and the page, and then gives us back a few things that we can use inside of our render function. And again, I want to be able to expose fetch images because if there was an error, I need a button that will let the user refetch those images. So let's take a look at how I implemented that useImages hook. So over here, I'm exporting that function and I'm taking in search term and page. But you'll notice in Vue here, I am making sure that these are actually refs. So because I want to see when those values change, I need to make sure that I actually get the reactive value. And so we define them as refs over here. And then inside of this custom hook here, I'll know when they change. I can use like the watch function and stuff like that. So if we look inside, I've got some state variables, then I've got my fetch images function. And in this case, I want to recall fetch images if search term or page change. And then to expose this function and state variables, I'm just returning an object. And that way inside of the component, I can actually pull those off and then use them inside of the render function. So that's how we create reusable functions in both Vue and React. Now let's take a look at how I'm handling that error state and also how I'm canceling in-flight requests. So there is this thing called AbortController. And you can create this and pass in its signal to a fetch request. And if that fetch request needs to be canceled for some reason, you can use the AbortController. So let's take a look at pagination here. So if I click next, that'll start loading the next page. But if I click next again, that'll load the page after that. And I want to cancel the request for the previous page. So I'll click next and then click next again. You'll notice that behind the scenes, that request got canceled. Now it errored out, but that's besides the point of cancellation. Essentially, make the request, cancel the previous one if it sees a new request come in while that request is in flight. Because if I click next and then the request for a previous page was still in flight, if it's not canceled, then it's going to update the state when that request comes back. And then we could be out of sync, right? Because I could be loading this page, it loads a previous page, and then all of a sudden I'm seeing the results for this page. Or in the worst case, the results for a previous page load after the results for the current page load. So it's important that you cancel those in-flight requests. Let's take a look at how we do this inside of React. So like I said, we have that abort controller. Now here inside of React, I'm using a ref. So a ref in React allows you to modify its current value without triggering a re-render. So for useState, we have this setter function, and we call that, and that's going to trigger a re-render. But with a ref, we just have the current value, and we can just set it and not trigger a re-render. And that's important because here inside of fetch images, we are setting the abort controller when we fire off that request. And if we were using useState, this callback would have to be dependent on it, but then we're updating it inside of this callback, and it would cause an infinite loop. So I'm using a ref. That ref starts off as null. Inside of this function, we abort the previous request. So if fetch images gets called again and there was an in-flight request, we're going to grab the current abort controller and call the abort method. Now, of course, it could be null because it's possible this is the first time we're firing this off. So I need to make sure I only invoke abort if the current value is actually set. Now, all of our state updates are the same. However, this API function that calls to get images now needs to return two things. It needs to expose that abort controller that it's passing under the hood to fetch, and then also expose the response, which is going to resolve to the results from that API request. So in this case, we get back both the controller and the response, and I'm updating the ref here. So I'm grabbing abort controller, grabbing its current one, and then setting it to this specific one. So each time we fire off a request, we're updating abort controller to be the current one for the current request. After that, we await the response and then update our state variables. But we need to also handle the error here. So we've wrapped the await for that specific API response in a try catch. And if it throws an error, we need to update the error message. However, if it was an abort error, we don't want to show an error message, right? We don't want to show the user that the previous request was aborted. We're just doing that behind the scenes. So if there was some kind of error, meaning the API errored out, we want to grab the message that the API responded with, set that on state, and so that way we can show the error message to the user. Now, the other spot where I am calling abort is inside of this useEffect. Now, technically, if I only cared about this page, I wouldn't have to return a disposal function because we are calling abort here, but we're treating this as our component did unmount. So if we navigate away from this page and there was a request in progress, we want to abort it. And so that's the main reason I have this disposal function. So for example, if I click next and then navigate away, we cancel that request because I'm not on that page anymore, so I don't need to worry about the response from that request. So this cancellation of requests actually works for multiple scenarios, not just pagination. So let's say a user types in a search term and then immediately types in a new search term. We want to cancel the request for the previous search term. And then this one errored out, so we're showing that error message, but we can try again with that search term. There we go. But again, we want the same behavior if the user is paginating, right? So if they're navigating to different pages, we want to cancel those previous requests. I probably should not have made this API error out as much as it does. Okay, but that's the React example. Now let's take a look at cancellation and error handling here inside of Vue. First up, we have our abort controller variable. You'll notice it's just a variable. I don't have to wrap it in ref or anything like that because I don't need to watch it for changes. And essentially, I just need the latest value. And one of the nice things about Vue is these hook functions don't get called over and over again. They're only going to get called once when the component is created, which means I'm only going to get one variable when the component is created. And then here inside of fetch images, I can check to see, is it null? If it's not, call abort. Update our state variables. And then again, we have this handler that comes back from get images, which gives us the abort controller and the response promise. Here, I'm just going to reassign the controller. So that way, every time this function gets called up at the top, I'm always aborting the latest request. We'll await that response. We have it wrapped in a try catch. So if it errors out and it was not an abort error, we will set that error on state and display the error to the user. Now, this is one of the nice things about Vue, and on the surface, you may not realize this, but all of this code that's defined here at the top of my function only runs once when the component is created. So even this invocation of useImages, that only gets called once, which means I can just have regular variables inside of here, and I don't have to worry about keeping track of what the current or latest one is like I do inside of React. So over here in React, we did use this useRef because I want to keep track of the same one on re-renders, and all of this stuff gets recalled again, so I need to make sure that I always have access to the correct current value. So in Vue, we don't have to worry about that. We can just use the variable itself. Now, to handle cancellation whenever the user navigates away, we just use onUnmounted. So this is a built-in function here inside of Vue, and you can call it even outside of components. But because this function was invoked in the context of a component, onUnmounted is going to get fired when that component is unmounted. And so here I can just say controller.abort whenever we navigate away from this page. So if we look at the Vue example, I can make a search, but if I navigate away, that request gets canceled. So that's it for this comparison. Now, I touched on these things earlier, but to really sum up the major differences and kind of why I prefer the Vue way of doing it is that useEffect inside of React is multi-purpose, right? It's component did mount, component did unmount. It's a watcher for dependency changes. It's a single thing used for a lot of different things, and you need to make sure that you're using it in the right way. Now, inside of Vue, we have purpose-built functions to do these things that we do often, right? So we have watch, so we can reinvoke a function if some dependencies change. We have onUnmounted to run some code when a component unmounts. We have onMounted to run some code when a component does mount. We also have some options that we can pass into watch, right? So we can actually opt in to running this thing immediately versus running immediately by default. And ultimately, when we're reading our code, it's much more explicit about when this stuff will run. Now, in React, you really have to read these functions to understand what their purpose is, right? And if you're in a large code base and you come across a component and you see a useEffect, you don't immediately know, is this a component did mount, component did unmount? What is this for? You actually have to analyze the code to understand better specifically what this useEffect is for. And so for me, that's the major thing that makes it harder to work inside of React code bases, is really just trying to understand each of these useEffects, because every single one is potentially different. Now, if you enjoyed this, be sure to subscribe, click that notification bell so you can be alerted whenever I drop the last video in this series, which is this stocks example. So this is a little stock dashboard. It allows you to add some symbols, reaches out to the Yahoo Finance API, and then updates the price in real time as it receives those updates from the Yahoo Finance API. So you can add as many symbols as you want, and then each one is going to have its own unique chart. And this is really an example of a highly interactive front end that has lots of asynchronous state updates and lots of nested components and different things like that. Thank you so much for watching. If you have any questions or comments about the code that I showed you today, leave a comment down below. And if you have any concerns or you think maybe you can implement the React example in a better way, let me know in the comments. And also, this code is completely open source, so check the link in the description. Feel free to open an issue or something like that if you think some of the stuff that I have done could be improved in any way. All right, I'll see you in the next one.